Hello and welcome to the last video lecture of spring 2020. This is section 7.1. As we begin, remember please, homework and quiz number 12 are due on Friday, April the 17th at 11:59 p.m. Central Time. Mastery Quiz 4, review for test 4, is due Sunday, April the 19th at 11:59 p.m. Central Time. Please remember that for the Mastery Quiz, you do receive 3 attempts if you would like to practice. Only the best grade counts. Test 4, which covers all of these sections, will be given at 9 a.m. on Monday, April the 20th, Central Time Zone. Students will be taking this on MyLabs Plus at 9 o'clock in the morning, Central Time. Let's get started with the last section. This is the only section that we do in Chapter 7. There are 2 different parts to it, but we'll combine this into one video lecture. The first part has to do with the non-applications, just simply solving systems of linear equations with 2 variables. When we talk in this section about 2 equations, we also talk about 2 variables or 2 unknowns. Most of the time they are x and y. As long as we have the same number of equations as unknown variables, we can solve a system. So in other words, if we have 2 equations, we need 2 variables. So the solutions to these systems are ordered pairs as long as there is a solution. To check those solutions, we simply plug the ordered pairs into both equations to see if we get a true statement. We'll begin by checking to see if either of these 2 ordered pairs are actually a solution to this system. So since we are given the system of equations, 2 equations, negative 4x minus 2y equals negative 2, and 5x plus 7y equals 16, we'll check first to see if the ordered pair negative 1, 3 is a solution to this system. Keep in mind that in an ordered pair, the first component is x, and the second component is y. So we will substitute these 2 values in for x and y in each equation to see if we get a true statement. So we'll begin with negative 4 times negative 1 minus 2 times 3. And we're asking the question, is this equal to negative 2. So is this equal? So the first part, we have 4 minus 6, and 4 minus 6 is indeed equal to negative 2. And that's what we're trying to check. So it works for the first equation. In order to be a solution for the system, it has to work in both equations. So now let's check the second equation. The second equation says 5 times the value of x plus 7 times the given value of y. Is this equal to 16? So that's what we're checking. So the first part, negative 5, plus the second part, 21. Negative 5 plus 21 is indeed equal to 16. So this point is a solution. Let's check the second point. Again, the first component of the ordered pair is x, and the second one is y. So we'll start with the first equation again. We have negative 4 times negative 3 minus 2 times 7. We want to know, is this equal to negative 2? So simplifying, we have 12 minus 14, and 12 minus 14 is indeed equal to negative 2. Everything looks good so far. Moving to the second equation, 5 times negative 3 plus 7 times 7, is this equal to positive 16. So we begin negative 15 plus 49. Well, negative 15 plus 49 is equal to 34. And 34 is not equal to 16. So this ordered pair is not a solution for this system of equations. So it can work in one equation but not the other, and that means it's not a solution for the system. Now, when we talk about solving a system of equations, we will get one of three different things that happens. So, if we solve the system of equations and we get an ordered pair, so over here what happens with the equations, as we're solving, we'll get a value for x and a value for y. And what this means is that that x and y component is the solution to our system. So we could have one solution. This means graphically, if we were to graph the two lines, they would intersect at one point. Now, if I'm solving the system of equations and all of my variables disappear, and I'm simply left with a statement such as 0 is equal to 1, or it could be something like 5 is equal to 7, something we know is a false statement, then we say that the system has no solution. Another way to write no solution would be to write this symbol, which means the empty set, a 0 with a line through it. This means that the two lines graphically are parallel lines, and parallel lines never intersect. So this also tells us that the solution to a system of equations is the point of intersection. If we're solving the system of equations and we get all of the variables to disappear, no x's, no y's, and we get a true statement such as 0 is equal to 0, 5 is equal to 5, something which is always true with no variables, then this tells me I have what's called infinitely many solutions. We'll talk about how to write a general solution for this. Graphically, what this means is it is two lines that are the same line. So if I were to graph each equation, I would end up graphing them in exactly the same places. So let's talk about how to solve these systems of equations. We'll begin, there are two different methods that we'll talk about. One method is called substitution, and the other is called the addition method. When we're solving, we'll either find a solution or discover there's no solution or infinitely many solutions, and we'll talk about how to write that. As we go through these, I'm going to talk about both methods, and you can pick your favorite. I usually tell students most people have a favorite method for solving systems of equations, and it doesn't matter to me which way you use. Sometimes I think one is easier than the others. Sometimes you might have a preference. MyLabs Plus will often point you in a direction. It will say solve by substitution or solve by addition. You do not have to do that. You can solve it however you want to. But the help feature will walk you through the method that it suggests. So let's begin with problem number 3 here. You can see our two equations, and in the first equation, it is solved for x. So it starts with x equals 4 minus y. If you have an equation where one variable is on a side by itself, that usually tells you substitution is a nice method for solving this system. So I'm going to use substitution to solve this system of equations. I'm going to do this by substituting 4 minus y in place of x in my second equation. So my second equation is going to become 3 times 4 minus y, and then I will continue. Minus 2y is equal to negative 3. So notice that in place of the x, I substituted my first equation of 4 minus y. Now we'll simplify this. This becomes 12 minus 3y minus 2y is equal to negative 3. Continuing to simplify, I have 12 minus 5y is equal to negative 3. Now subtracting 12 from both sides, we get negative 5y is equal to negative 15. Dividing both sides by negative 5, we get y is equal to positive 3. Notice that when we get y first, that is the second part of my ordered pair. So the ordered pair or solution is going to have an unknown x component and 3 for the y component. Now we're going to go back and find x. The first thing I do want to point out to you at this point, though, is since I found a value for y, this means my system is going to have one solution. So now to find the value of x, we're going to use x is equal to 4 minus y. We'll substitute 3 in place of that y. Simplifying this, we get x is equal to 1. So the ordered pair 1, 3 is a solution for this system of equations. We can check this. We'll come to the side over here to check. We want to check it in the second equation since I used the first equation to get my solution. So this means I have 3 times 1 minus 2 times 3. This gives me 3 minus 6, which does indeed equal to negative 3. And so I can check it by plugging it into the second equation. Excellent. So let's move on to problem number 4 here. We're going to also use substitution on this one because I know a lot of you like to use that y here and it helps you to solve by substitution. In order to solve this system by substitution, though, we need to solve for this variable. So I'm going to start by subtracting 2x from both sides. That would give me negative y is equal to negative 2x plus 3. I need to solve this equation for y, so now I'm going to multiply everything through by a negative 1, and I have positive y is equal to positive 2x minus 3. So now I have an expression for y that I can substitute into my second equation. So my second equation is going to become negative 8x plus 3 times, and this is where I'm going to substitute my y value in, is equal to negative 8. So in place of that y, I'm going to drop in my expression 2x minus 3. Now I'm going to simplify my equation. So simplifying the left-hand side, negative 8x plus 6x minus 9 is equal to negative 8. Simplifying further, I have negative 2x minus 9 is equal to negative 8. Adding 9 to both sides is going to give me negative 2x is equal to 1. And dividing both sides by negative 2, I get x is equal to negative 1/2. So again, I have a value for one of my variables. This time I have the first component of my ordered pair. So my solution is going to be negative 1/2 something. So now I need to use that value for x to find y. So y now is equal to 2 times, we'll plug in that negative 1/2 and then subtract 3. So 2 times negative 1/2. 2 times negative 1/2 becomes negative 1 minus 3, and I get a y value of negative 4. Again, I can substitute the negative 1/2 and the negative 4 into the second equation to check, but I do indeed get negative 8. I think I need to move my screen up just a little bit. There we go. There's problem number 5. All right. So problem number 5, I think, works very nicely with the addition method. And I'll tell you the difference here. Even though I have a single x and a single y, if I add the two equations together, and that's what we would do in the addition method, I can get rid of one of my variables. And that's really the goal here. So if I can simply add my two equations together, adding the like terms, and get rid of an x, sometimes this is known as the elimination method because we are eliminating a variable. So let's see what happens when I add. I get 0 x's. I do get 28y is equal to 35. Very nice now. I can divide both sides by 28. I have 35 divided by 28. Both of these pieces are divisible by 7. So if I divide 7 into the numerator, I get 5. And 7 into the denominator, I get 4. So y has a value of 5/4. Now this problem is a little bit unique in that in order to find the x value, I'm going to substitute, or I'm not going to substitute, I'm going to go back and solve the system a second time. And I'll tell you why, and that's because of this 5/4, this fraction that I would have to substitute in for y. Makes for just a little bit of a messy problem. Now, in order to solve this equation a second time, what I'm going to do is I want to get to the point where I have a positive 14 in one equation and a negative 14 in the other equation. So I'm going to do that by multiplying the second equation by a negative 1. So let's start by taking the first equation of x plus 14y is equal to 20. And the second equation, we're going to multiply by negative 1. That's going to give me positive x minus 14y is equal to negative 15. Now as I add these two equations together, I get 2x, 0y is equal to positive 5. Dividing both sides by 2, I get x is equal to 5/2. So sometimes you can go back and solve the system a second time using a different method or different variable elimination, and it makes it easier than substituting backwards to find the second value. Totally your option. Let's look at problem number 6. We have 3x minus 2y, and we have a 2x and a plus 6y. There's no single x or single y, and I can't just add the equations together to get rid of a variable. However, if I look at this first equation, negative 2y, and the second equation with a positive 6y, if I multiply the first equation by 3, I will be able to eliminate the y's. So let's multiply the first equation by 3. That's going to give me 9x minus 6y is equal to 60. And the second equation is going to stay the same. It's going to be 2x plus 6y is equal to negative 38. Now as I add my two equations together, I get 11x is equal to 22. Now that was not as bad as we thought it was going to be. Dividing both sides by 11, I get x is equal to 2. So my solution, I found the x value to begin with, so 2, and I need to find the y value. Now you might be asking how we're going to do that since I have neither equation solved for y. Well, I can go back to either of these two equations. I'm going to choose the first one just because simply it is the first one. And I'm going to substitute the value of 2 in for x. So I have 3 times 2, and then we'll continue. Minus 2y is equal 20. And now I can solve for y. So I have 6 minus 2y equals 20. Negative 2y will be equal to 14. And dividing both sides, I get y is equal negative 7. And so my solution is 2, negative 7. And once again, since I used the first equation, I can plug it back in. That would give me 4 minus 42, which is negative 38. Let's look at problem number 7. Number 7, I could solve for either x or y, but I am going to use elimination to solve this system. I'm going to multiply the first equation by I'd like you to guess or think what you think it should be. Hopefully you said positive 2. When I multiply the first equation by positive 2, I have 2x plus 2y equals 6. My second equation doesn't change. Negative 2x minus 2y is equal 1. I add my two equations together. Notice what happens. I have 0x and 0y. So I have 0 on the left-hand side is equal to 7 on the right-hand side. Now, the last time I checked, even in this crazy world we're living in right now, 0 does not equal to 7. So we say that this is a false statement. And since it is a false statement, we say that the system has no solution. Again, you might see this written as the empty set, which is this circle with a line through it. Let's move on to problem number 8. Again, in this one, I do have y is equal to negative 8x. There's no constant out there, but that's okay. There's nothing wrong with that. So in this one, since I do have one equation solved for one variable, I'm going to use substitution. So I'm going to substitute my value of negative 8x into the first equation in place of y. So this is a little bit different than we did on the first problems. So my first equation becomes 8x minus, and remember in place of y, we're going to substitute negative 8x. And this is all equal to negative 13. Now simplifying this further, on the left-hand side, I'm going to get 8x plus 8x, and so I'll have 16x is equal to negative 13. And then x will be equal to negative 13 over 16. That is the first component in my solution. So now you've seen the difference between getting a false equation or statement and having no solution, and again, actually getting a value. If I get a value for either x or y, I have a solution. So let's talk about finding y. Well, we know y is equal to negative 8x, and this one won't be quite as bad as some of you were thinking with the fraction. So I have negative 8 times negative 13 over 16. 8 will actually divide into 16, so I'm going to write it a little bit different. Negative and negative is positive, and so I have 8 times 13 over 16. That 8 divides into 16, and it leaves me with 13 over 2, and so 13 divided by 2 is the second component for my ordered pair, my solution. Excellent. Let's look at problem number 9. Several examples because each one of them carries with it a little bit something unique. So in this one, I might try solving for y, and I know several of you are going to want me to do that, so I'm going to do that. I'm going to take this equation and solve it for y so I can use substitution. So I have y is equal to negative 2x plus 5. And now I'm going to use this to substitute into the first equation. So my first equation is going to become 8x plus 4 times, and in place of y, now we'll substitute negative 2x plus 5. And this is all going to be equal 20. Now simplifying this left-hand side, we have 8x minus 8x plus 20 is equal to 20. 8x minus 8x goes away. We have no variables left. But we do have a statement that says 20 is equal to 20. Now this is a statement which is true all of the time. And so this means that we have infinite solutions, and we need to talk about writing the general solution. So infinite solutions, there'll only be one choice if the multiple choice that says infinite solutions, so that won't be too bad. So let's talk about what that general solution looks like. So a general solution is going to be an ordered pair. If one of our equations is solved for one of the variables, then this is typically the way we're going to write this. So for our general solution, we'll use the variable x, and then in place of y, we'll substitute in, or we'll simply write negative 2x plus 5. And this is what we call a general solution in terms of x. And so it will tell you to write your general solution in terms of either x or y. So this is a general solution in terms of the variable x. And that's it. Let's move on to number 10. In this one, I am going to use the addition method. And I'm going to use addition by multiplying the second equation by positive 3. As I multiply the second equation, that does not change the first equation. So I have negative 3x plus 6y is equal 9. And the second equation becomes positive 3x minus 6y equals negative 9. I add these two equations together, and what happens is negative 3 and positive 3 go away, 6 minus 6 goes away, and I have 0 is equal to 0. Again, a true statement. So this is true. This means we have infinite solutions. And again, we need to write the general solution. Well, so just for some variety, we're going to write this general solution in terms of y. So general solution in terms of y. And I'm going to show you how that is different. So in terms of y means in my ordered pair, I'm going to have y. So now what I need to do is I need to find an expression for x that involves y. So if I look at this second equation and I take x minus 2y is equal to negative 3, and I solve this for x, that means I'm going to add 2y to both sides, so I get x is equal to 2y minus 3. Now I have an expression for x in terms of y. And so the first component of my ordered pair is 2y minus 3, and then the second component is y. So now you have an example of infinite solutions where the general solution is solved in terms of x, and infinite solutions where the general solution is written in terms of y. The next thing we'll do is look at a couple of application problems. So application problems mean also word problems. And we're going to do a couple of different types of problems involving systems of equations. So let's start with Bully & Associates is a real estate developer. They recently built 200 condos in Starkville, Mississippi. These condos were either 2-bedroom units or 3-bedroom units, and the total number of bedrooms in the entire complex is 507. Unfortunately, they forgot to count how many 2-bedroom and 3-bedroom units they built. And so we are tasked with the job of discovering that. So the first thing we're going to do is name our variables. So we'll start by using x and y. So we're going to let x be the number of 2-bedroom units, and we'll let then y be the number of, you guessed it, 3-bedroom units, because those are the two unknown quantities that we have. Now we're going to use this information to write a couple of equations. So we know that the total number of condominiums built in this complex is 200. So that means we know that x plus y must be equal to 200. Now the second equation comes with the second large number we have here, which is 507. 507 is the total number of bedrooms. How many bedrooms does a 2-bedroom unit have? You guessed it, 2. So we're going to use 2x plus the 3-bedroom unit has 3 bedrooms, so 3y this total is equal to 507. Now we have a system of equations to solve. I know many of you like to solve by substitution. I can hear it in the air. So we are going to solve this first equation for y. So y is equal to 200 minus x. I'm going to substitute this into the second equation. So the second equation becomes 2x plus 3 times 200 minus x. And this is going to be equal to 507. Now I can simplify and solve. I get 2x plus 600 minus 3x is equal 507. This gives me negative x plus 600 is equal to 507. If I subtract 600 from both sides, I get negative x is equal to, oh good, it's a negative 93. I was really a little worried, not really, about this negative x, because can x be negative in this problem? And the answer is absolutely not. Why not? Because you are not going to have a negative number of units. Or you're not going to be renting a whole lot of condominiums or selling them. So if I divide both sides by negative 1, I get x is equal to 93. Now, in order to finish solving this problem, I need to find a value for y. So y we know was equal to 200 minus x, so 200 minus 93. And y is equal to 107. Now, here comes the last part of this problem. Whether it's homework or a quiz or a test, you are going to be asked to answer the question, how many 2-bedroom units and how many 3-bedroom units? So we need to know what each of these represents. So it will say blank 2-bedroom units, and then it will ask you blank 3-bedroom units, and you need to know which one goes in which place. Well, x represented the number of 2-bedroom units, so we can with confidence say there were 93 2-bedroom units, and y represents the number of 3-bedroom units, so there are 107 3-bedroom units. Labeling your variables is key to answering the questions. Sometimes it will just ask you for one or the other. So you have to make sure you know which value goes with which quantity. So on a certain hot summer day, 492 people were in a swimming pool. The daily prices were $1.50 for children and $2.50 for adults. The receipts for admission totaled $929. How many children and adults were in the pool that day? Now, if we were in class, we would have a whole long discussion about swimming pools and just dropping your kids off, but we can't do that. So if you've ever experienced a very hot summer day and you'd like to share with me how you enjoyed the pool, feel free to drop me an email and tell me about your swimming pool experiences. I would love to hear about them. Now, for this problem though, we simply have to solve the equation. So we need to know what our variables are, and our variables are going to be the number of children and number of adults. So let's let x represent the number of children, just simply because it comes first in the problem, and y will represent the number of adults in this equation. Now we have two different types of numbers. We have money numbers and we have number numbers. So we're going to start by using the number. And we know the number of children plus the number of adults totaled 492. Now for the money problem. $1.50 for every child and $2.50 for every adult. So our money equation is 1.5x plus 2.5y equals 929. Keep the money with the money and the non-money with the non-money. You can put the 0 at the end if you want to. It just clutters up the equation. This one does solve very nicely using substitution. Since it's asking for both quantities, it does not matter which one you solve for. Most people like to solve for y so they can substitute that in. It's really a personal preference. Either way, we've got some decimals here, but it's not going to be bad, I promise. So 1.5x plus 2.5 times y, and now we'll substitute this 492 minus x, and this is going to be equal 929. Now as we simplify this a little bit further, I have 1.5x plus, I'm going to get my calculator while you get your calculator, 2.5 times 492 is 1,230 minus 2.5x. Now some of you might be just a little bit concerned because we have some decimals in here. We are not going to end up with a decimal. If we end up with a decimal, we are probably in lots of trouble. It's hard to have part of a person in this swimming pool, or it's kind of gross to have part of a person in the swimming pool. So we need to have whole numbers for x and y. Also, even though some people have negative attitudes, we do not have negative numbers of people. So they have to be positive values. So let's finish simplifying this side. So 1.5 minus 2.5 is going to give me negative x plus 1230 is equal to 929. Subtracting our 1230 from both sides, we get negative x is equal to negative 301. But we now know that positive x is equal to positive 301. How do we find y? We go back to this equation and we say y is equal to 492 minus 301. And that tells us that y has a value of 191. Now, what's what? How many children and how many adults? So the problem will probably say blank children were in the pool and blank adults were in the pool. And so we know that x represents the number of children, and we solved for x and we found x to be 301. And y represents the number of adults, and we found y to be 191. If you add these two numbers together, we should get 492. And it does make sense that there are more children than adults in the swimming pool. Who knows? I'm glad there's some adults there to supervise the children. See, we could have had a great discussion about swimming pools. So sorry I missed it with you guys this semester. Let's look at problem number 3. Robert invested a total of $5,900 at 2 separate banks. One bank pays simple interest at a rate of 12% per year, whereas the other pays simple interest at a rate of 7% per year. If Robert earned a total of $568 in interest during the first year, one single year, how much did he have on deposit in each bank? Because Robert forgot how much he put at each bank, so we have to help him out here. So we're going to let X represent the amount at the 12% bank, and Y will represent the amount at the 7% bank. Now, one more thing we do need to talk about is how do I find simple interest? Now, I'm pretty sure we talked about this at the beginning of the semester, but just in case you don't remember, interest is equal to principal times rate times time. But since time is a single year, we can simply use interest is equal to principal times rate. Now, I like to draw a little box here, and so I'm going to draw a box and hopefully make it kind of nice and pretty for us. And we're going to put some pieces in this box. I think this is the easiest way to help you lay out the solution for this equation. So we need to put some things together. So this is going to be the principal, and this is going to be the rate, and this column is going to represent the interest, which is the principal times the rate. Now, we have three different things going on here, so let's kind of divide this part up also. So the first thing we have is bank that has 12% interest. So this is the bank which is operating at 12%. Okay? That means the interest rate is, you got it, 0.12, 12%. We do have to change that percent to a decimal for these problems. So the bank which is offering the interest rate of 7%, you guessed it, the rate here is 0.07. So far we're doing great. The last row here is our totals. Okay? So what we know for a total amount that was invested is that it's $5,900. Now how much was invested at 12%? Oh, that's our X. And how much was invested at 7%? Yep, that's our Y. Now, what is our interest at the 12%? Well, it's the principal times the rate. Two places right here. The interest at 7% is the principal times the rate. The interest for the total amount, you got it. It is $568. So we're going to write 568. Now, you will not ever need this blank. This blank will remain empty. So we're just going to fill this in and not put anything there. Okay? All right. So let's get started. Multiply across. We've done that. Now we're going to add the last column. So by the time we get to this, we have done the hard work and we're going to write a very nice equation. So our first equation is going to actually come from our first column. So let me highlight this one for you. We'll go pink here. So we want, this is our first equation, and this is going to be our second equation. So first equation is X plus Y equals 5,900, long day. Second equation is 0.12x plus 0.07y is equal 568. Excellent! You're getting the hang of this. Let's take the first equation and solve for y. So I have y is equal to 5,900, and I'm going to minus x, and I'm going to substitute this in for y in the second equation. So the second equation now becomes 0.12x plus 0.07 times 5,900 minus x equals 568. We'll clean this up. 0.12x plus 5,900 times 0.07 gives me 413 minus 0.07x is equal to 568. Again, we will not be getting negative numbers. Banks typically do not like you to invest a negative amount of money and expect to get anything for your return. Cleaning this up, we get 0.05x. I'm going to go ahead and subtract our 413 from both sides. That's going to give me 155. And then if I divide that by 0.05, I'm going to get x is equal to 3,100. Now, since I invested, or Robert here invested $5,900, it makes sense that one of those two investments was $3,100. Okay? So we can say then with confidence that $3,100 was invested at what rate? Yes, at 12%. Excellent, because that's what our x is. Now, how do we find y? Well, we find y by going back to this equation. So y would be equal to 5,900 minus 3,100. And y, therefore, is oops, not 48. I cannot subtract today, sorry. Let's try 18. Let's try one more time. Long day, sorry guys, I can subtract. Let's try $2,800. Whew. Okay, and so that means that 2,800 or 2,800 was invested at 7%. Excellent. Very good. Let's talk about the nut shop problem. Mike, who owns Mike's Nut Shop, sells peanuts and cashews. Peanuts for $3.25 a pound, cashews for $6 a pound. Mike wants to create a 58.5-pound barrel of mixed nuts and sell that mixture for $4 per pound. How many pounds of each should Mike use? You should recognize this as a yes mixture problem. So we're going to do exactly the same thing that we did with mixture problems the first time we solved these. And that is we're going to create containers. Now remember, in my containers, in the top part of my container, I'm going to put a price. And in the bottom part of the container, I'm going to put pounds or amount. Okay? And so we have two containers that we are going to put together to make a mixture. So the first container is going to represent the peanuts. So we can write peanuts up here so we don't forget. And the second container is going to represent the cashews. And this is going to be equal to our mixture. Now, if you liked what we did the first of the semester, you can actually go back and use that. If you like this, you can go back and use this method for solving those problems. Totally up to you. What do we know? We know the price for the peanuts is $3.25. Let's just go through and put what we know in here. We know the price for the cashews is $6. And we know the price he wants to sell the mixture for is $4. Excellent. We have one amount. Mike wants to create a 58.5-pound barrel of the mixture. So that means that 58.5 is the number of pounds for the mixture. This means I need an X and I need a Y. And so X is going to go with peanuts, Y is going to go with cashews, and now we can write our equations. The first equation is going to be from the bottom of the containers. So the first equation is going to come just straight across the bottom. And it is going to look like this. X plus Y is equal 58.5. And the second equation is going to be just like we did before. Top times bottom, so 3.25x plus top times bottom, 6y, is equal top times bottom, 4 times 58.5. Take the first equation, solve it for y. Y is equal 58.5 minus x. Substituting this into the second equation, 3.25x plus 6 times 58.5 minus x equals, I'm going to go ahead and multiply those two numbers together. So 58.5 times 4 is going to be 234. And we're going to simplify this. So 3.25x plus 351 minus 6x is equal to 234. Cleaning this up a little bit, I have negative 2.75x plus 351 is equal to 234. Don't worry, we will not end up with a negative number because we do have a negative to divide by. And so I'm going to have negative 2.75x is equal to negative 117, dividing both sides by negative 2.75 is going to give me a decimal, and that's okay. So 42.545 and some change. We're going to round to the nearest tenth. So x is going to be 42.5 pounds. So how many pounds of each? We need to use 42.5 pounds of peanuts, and then since it does say of each, we need to find how many pounds of cashews. So we will substitute that number in for my equation here. So 58.5 minus 42.5 is going to give us a y value of 16. So 16 pounds of cashews. Okay. One more problem, and I promise we are done. You've probably paused somewhere along the way and realizing why this takes 2 class periods usually to cover this material. But you can break it up however you want to. Last problem, pizza and soft drinks. You're all drinking soft drinks, right? Yes, excellent, very good. Okay, or water. So the total cost of 5 slices of pizza and 2 drinks is $16. The total cost of 6 slices of pizza and 3 drinks is $20.25. What is the cost of 1 slice of pizza? Now this problem is different in a couple of ways. One, we don't have a total amount of anything like we did in the previous problems. And 2, we're only looking to find one of the variables. We have 2 variables, but we're only looking to find one of those. So let's go through and let's let x represent the cost of 1 drink. And we're going to let y represent the cost of 1 slice of pizza. And that's going to help us out quite a bit. Okay? So we're going to take the 2 statements that we have and translate those into math. So 5 slices of pizza and 2 drinks is $16. That first statement becomes 5y plus 2x equals 16. Notice that I called y my slices of pizza, so I have to put y with the 5. That's okay. You can call them x as long as you label them. We're good. It's going to be fine, I promise. So the second statement is 6 slices of pizza plus 3 drinks is $20.25. Now, for this particular problem, I really want to solve for y. So what I want to do is I want to get rid of the x's. So let's multiply the first equation by 3 and the second equation, we haven't done this yet, by negative 2. And that's going to give me a 6x and a negative 6x. And we will be able to eliminate the x's because we're trying to find out the price of a slice of pizza. So let's go through and do this process. So this is going to become 15, let me write that correctly, 15y plus 6x is equal to 48. And the second equation is going to become negative 12y minus 6x is equal to negative, it's not 50, sorry, negative 40.5. Okay? All right? And now we're going to add these together. When we do, we eliminate the x's. We get 3y is equal to 7.5. Again, this better be a positive number. We get negative numbers and we end up in lots of trouble. So y is equal to 2.5, but because it's money, we're going to add that 0 on the end. So the cost of a slice of pizza is $2.50. $2.50 for 1 slice of pizza. That ends the video lectures for College Algebra for the spring 2020. I hope by now you've joined me on a WebEx or a Zoom session or sent me emails and that you're doing well in the class and are getting ready for test 4 and then our final exam. We'll try to do some fun review sessions online. Guys, I really hope everything is going well for you and that these videos have been helpful. Y'all have a great day. Goodbye.